And with any further delay, I would like to give the floor to INTAERO Limited to present that solution.
Thank you.
Let me, okay. Can you try to share your screen?
Yes, I am doing that. How's that? Very good. Yes. Thank you.
The floor is yours.
Okay. Thank you. I'm James Giles. I'm a former RAF operational pilot and a test pilot. When I left the RAF, I set up INTAERO in the UK. I currently live in northern Thailand, which is where I'm calling from today. We had two main areas of interest. One was aircrew training, and the other, more importantly, was military systems integration. Now, 3 years ago, I was in China when 27 firemen died when the wind changed and they were basically cut off. And I realized that what the military had in network-centric operations was what was needed in firefighting. So 3 years ago, I suspended the military operation and redeveloped the product into what is now, I'm presenting today, DART, Disaster Alleviation in Real Time. I'm going to brief a couple of points which always come up when I'm talking to firefighters particularly. Firstly, what is DART? Secondly, how do we provide communications when it's off-grid, that is, no GSM, no internet? How do we network all the stakeholders, all the interested people, all the decision makers? Where is the fire? Where is it going? Most important. How do we integrate air assets and then air and ground assets? And most important, how do we keep first responders safer? So let's go over what DART is to begin with. As I mentioned, it's developed from real-time military command and control system. And basically, it's there to enable network-centric operations. It's a military term, but it applies extremely well to disaster management. DART is a nodal software. That is, it's not a server client. It doesn't have to send data back to a server and then receive it. So each mobile unit of DART sits on a mobile computer. It receives, it views, and it transmits all data in real time. And it transmits to all decision makers and all stakeholders. Now, there are many benefits in network-centric operations in disaster management, very similar problems as faced by the military. How do you get shared situational awareness to all stakeholders? You can distribute decision-making to the lowest possible level. You can support interoperability. You can increase the speed of command and get from that a higher tempo of operations. And again, more importantly, operate more safely. So let's talk about off-grid communications. Firstly, all the first responders can be given one of these low-rad GPS trackers, which we've developed at INTAERO, especially for this use. They all respond and report up to their team leaders, and the team leaders network with each other using IP mesh radios from rugged tablet computers, as you see there. They also network up to the incident commander and his team, who uses mesh to receive the data from the team leaders, and then internet or satellite or GSM, if it's available, to connect up to the regional and national headquarters. You can see on the bottom right that DART uses icons and action buttons for ease of use. You don't need to be computer literate to use it. We use data, not voice, so that we get clear, unambiguous communication. And importantly, commands, messages, and the interface can be set to any language. And if you can see on the bottom right there, this is actually in Chinese. What's important about this is we can distribute decision-making. We use low bandwidth messages sent in real time so that it doesn't clog up the network. DART then turns these messages into graphics, which makes it really easy to extract crucial information. So let's look at the organization. We have DART tracker with every member of the first line personnel, every first responder, every firefighter, or everyone working the flood. They then communicate up to the team leaders using DART ground. The team leaders communicate with each other and with vehicles. Dart Air, which is similar to Dark Ground, is designed to go on aircraft and integrate UAVs, and they communicate with each other and, importantly, with the incident commander, who uses a version of the product called DartNet, and he can use that to communicate up, for example, to an emergency response coordination center. So that's how the network flows, or the information flows up the network. Now, a question is always asked, where is the fire? Well, this is the way that we do it. We take regular images using an IR camera, either on helicopters, UAVs, or whatever. And you can see on this image here how you can see the fire line through smoke using infrared cameras. So we can extract that fire line and outcrops from the images using artificial intelligence. Save that as a Kml file and process it, importantly, within minutes. Satellites are great, but they take hours or even days to get data back to the decision makers. Once we have that data, which is the file, we can share it using Dart and display it. And at the bottom here, we see some lines. Red is the actual fire, yellow is the predicted fire, and this is the growth of a fire actually in Australia. We then send public warnings using the Common Alerting Protocol 1.2. We actually developed an application of this so we can warn the general public. DartNet, importantly, can input third-party data. We can input weather. You can see winds here, and that can be shared. GIS information and fire prediction tools like Prometheus, which is a Canadian tool for planning fire growth. Dart Air is basically using the same tablet idea of a tablet computer mesh radio on the aircraft to complement voice radio. It creates situational awareness for all aircrew and vastly increases safety for the air operations. So the operators can see every other aircraft. Importantly, the ground people can see every aircraft, every UAV, and they can coordinate them. We can input, for example, location of water sources, drop zones, and show the direction that we want an aircraft to fly and the very specific point that he's required to drop water. How do we keep firefighters safer? Well, firstly, all frontline personnel share the position and status with their team leaders using the LORA tracker. The team leaders then share data with each other and the incident commander using mesh radios. The tracker has an alarm, it has a vibrator, and it also has a GUI. It has a screen which can show a safe direction of travel, show commands, go home, return to base, whatever. All messages to the tracker, importantly, can be any local language. So we can create interoperability. We can distribute trackers to people from different nations speaking different languages, and they can use it in their own language. Dart automatically warns if a person is in a danger zone. Dart creates zones, and as you'll see on the video in a moment, we can show where people are. And then the commander can send vehicles to evacuate the people as required. So this is what Dart looks like. This is a fire in Australia. The yellow, I'm just going to run the video through here and show it. So this is a training mode, so everything's actually moving. We're looking at a helicopter here and showing that we can actually stream video from a helicopter into DartNet so we can get video around as well. Not recommended for low bandwidth networks because it kills the network, but very good for using the incident commander level. And I just clicked it and restarted it. My apologies for that. So we can get videos around and we can also show information. The next information we're going to show is actually the fire location and the fire spread. And these are files, these are Kml files. So what you can see at the top here, we have a way of changing the time. We have a slider. We can set the time and see where the fire is at that specific time. That is the time the image was taken and processed and then sent down to the system. So this, I've just gone on the network now. I've opened the network, and on the network is another Kml file coming in. It's now in yellow. Immediately I get a warning that these people are in danger. And I'll just put up so I've got a warning here. 3 people in danger. I can use a command and send them information which they'll receive on their tracker. It's showing flashing. It will go solid when they acknowledge it and acknowledge receipt. Now, how do I want to get them out? Well, there's a truck down here that can help them. So let's tell him to evacuate these people. And where are they? Well, we'll link up the truck and the people and show how this is moving, intercept that, and this is real time. It's showing where the people are moving and where they have to get, where the truck has to go to pick them up. So this is how we share information in real time. And I think that just concludes my presentation, hopefully within the 10 minutes. Thank you very much. I'm James. More information on the website if you choose to look at it. Thank you.
Thank you very much for presenting, respecting the time, the strict time, and apologies we only have 10 minutes because you have plenty of information to share and so, and it is real time. So